Now we are going to discuss problem number 16. It said 7 identical circular planar discs, each are having mass capital M and radius capital R, right? So you have to find the moment of inertia of the arrangement about the axis normal to the plane and passing through the point P. So about this particular axis that is passing through P, you have to find the moment of inertia of the system. Now we know if we consider this system, its center of mass must be lying at a center point, that is point O. So the first thing that we will do, we are going to find the moment of inertia of the system about this point O. And then we can simply apply parallel axis theorem to get the moment of inertia about an axis passing normal to the plane and passing through P, right? So first we will do what? We know that moment of inertia of disk, let's say this is the disk, if I say about any axis that is passing through the center and perpendicular to the plane of the disk, so moment of inertia will be half into mass of the disk into square of radius about this axis. Let's say this is having R, this is axis x dash, and it is having mass capital M. This is what we know, right? Now we are going to find the moment of inertia of system about an axis passing through O. What will be? So for this particular disk, it will be half mr square. So for this disk, it will be half m capital R square plus. Now see, each of the remaining six disks are located at a distance of 2r from the point O. So this R and this R. So what we will do? We can write for each one of the disks the moment of inertia about their own center, perpendicular about an axis perpendicular their own center, plus the distance of that particular center point from O. That is by using parallel axis theorem, right? And that same result we can obtain for the 6 different disks. So see, for this we will get plus 6 into half mr square plus m into twice of r whole square. So this particular term half mr square plus m into twice r square is for each disk, and we have got 6 similar disks like that, right? So this will be the moment of inertia of the system about point O. So this is equals to half mr square plus 3 mr square plus 4 into 6, 24 mr square, right? So it will be 27 half plus 27 mr square, and it will be what? It will be 55 upon 2 mr square. So what we have done in this particular case, we have just applied parallel axis theorem, right, for each of these disks. Now we have got the moment of inertia of the whole system about this point. Now what we have to find? We have to find the moment of inertia about this point P. So we know we can write the moment of inertia about an axis passing through the normal, through the normal of the plane. It can be written as moment of inertia of the system about O plus m into this distance square, and this distance is how much? This distance is 2r plus r, that is 3r, right? So I can write moment of inertia of the system about point P is equals to moment of inertia about O plus, now total mass, that is let's say m total into 3r square. Now what will be m total? M total will be 7m because there are 7 such disks, right? So the required answer, that is I about P, is equal to 55 upon 2 mr square plus 7m into 9r square. Fair enough? So this IP will be equal to, take mr square common, it will be 55 plus 63 into 2, that is 126 upon 2. So it will be 126 plus 55 is 181 upon 2 mr square. So the correct option is option 2. Correct option is option 2.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.